From our little corner of the universe, the Milky Way looks like a calm, glittering river of stars stretched across the night sky. But don't let the peaceful view fool you. At its very heart, 26,000 light-years from Earth, a monster is lurking in the shadows. It's a gravitational beast with the mass of 4.3 million suns, a supermassive black hole we call Sagittarius A. For most of human history, it was totally invisible, hidden from us by a thick curtain of gas and dust. So, how did we finally find it? And what other secrets is it hiding? Let's take a journey to the chaotic center of our galaxy and uncover the truth. Trying to see the center of our galaxy isn't easy. For centuries, astronomers pointed their telescopes toward the constellation Sagittarius, where the heart of the Milky Way should be, and saw, well, not much. Instead of a brilliant cluster of stars, they were met with enormous, dark clouds. This is the zone of avoidance, a massive barrier of interstellar gas and dust that blocks almost all visible light. For early astronomers, it was like a frustrating blank spot on the map, a total mystery. But when one path is blocked, you find another. Astronomers realized that while visible light was stopped cold by the dust, other kinds of light could sneak through. So, they built telescopes that could see in different wavelengths like radio waves, infrared, and X-rays. These invisible forms of light, pouring from hot gas and distant stars, cut right through the cosmic fog. By looking at the sky in a whole new light, we finally took our first real step towards solving a 26,000 light-year-old puzzle. The first clue about what was hiding at the galactic core didn't come from a picture, but from a sound, or at least, its radio equivalent. In 1974, two astronomers, Bruce Ballack and Robert L. Brown, aimed a powerful radio telescope at the center of the galaxy. They found a bright, tiny, and very weird radio source. They named it Sagittarius A, or CGRA for short. This was a big deal. Whatever was making these powerful radio waves had to be incredibly energetic, but packed into a surprisingly small space. It was a whisper from the heart of the galaxy, but it was a loud one, and it needed an explanation. So what could be that small, yet that powerful? At the time, physicists were obsessed with one of the strangest ideas in the cosmos: black holes. The theory went that there were stellar mass black holes made from a single collapsed star, and then there were supermassive black holes, beasts weighing millions or even billions of times more than our sun, acting as the engines in the center of most big galaxies. A black hole is a spot where gravity is so intense that nothing, not even light, can escape once it crosses the event horizon. The idea was tantalizing. Could CGRA be our very own supermassive black hole? The hunt was on to prove it. Proving something exists when it's literally invisible is a bit of a challenge. You can't see a black hole, so how do you prove it's there? You watch what it does to the things around it. That was the brilliant idea behind the work of two teams of astronomers, one led by Reinhard Genzel, and the other by Andrea Ghez, who would later share a Nobel Prize for their discovery. Using incredibly powerful telescopes, these teams spent decades patiently mapping the movements of stars right at the center of the Milky Way. They were watching a cosmic dance, and one star, S2, was the lead performer. Over 16 years, they watched S2 complete a full, wild orbit. As it got close to CGRA, the star accelerated to insane speeds, hitting almost 8,000 kilometers per second. That's nearly 3% of the speed of light. It whipped around an unseen point in space before being flung back out again. There's really only one thing that can make a star move that fast in such a tight loop. Something with a mind-boggling amount of gravity, crammed into an impossibly small space. Using Kepler's laws of motion, the astronomers calculated the mass of the object at the center of the orbit. The number they landed on was staggering, about 4.3 million times the mass of our sun, all packed into a space smaller than our solar system. This was the smoking gun. The dance of the stars around CGRA was overwhelming proof that it was, indeed, a supermassive black hole. We had the proof. We had the mass. But we still didn't have a picture. The ultimate prize would be to actually see the black hole's shadow against the glowing gas swirling around it. The problem? Even though it's massive, CGRA is so far away that it appears about the size of a donut sitting on the moon. No single telescope on Earth was strong enough to get that shot. So, astronomers came up with a crazy, brilliant plan, the Event Horizon Telescope, or ET. The ET isn't one telescope, it's a global network of radio telescopes, all working together as a single, virtual observatory the size of our entire planet. For years, more than 300 scientists from all over the world worked to pull this off. They had to deal with Earth's turbulent atmosphere and the fact that the gas around CGRA is moving so fast its appearance changes from minute to minute. Then, in May 2022, they showed the world what they had found, the very first direct image of Sagittarius A. It was incredible. The picture revealed the black hole's telltale signature, a dark central shadow, the event horizon itself surrounded by a lopsided, brilliant ring of superheated gas spent by extreme gravity. For the first time, we could finally see the monster at the heart of our galaxy. And the size and shape of that ring matched Albert Einstein's theory of general relativity perfectly. Once again, Einstein was right. Okay, so we've seen the monster. What does it actually do all day? Is it constantly gobbling up stars and planets? The answer is mostly no. Compared to the black holes in other galaxies, which are tearing things apart and lighting up the cosmos, CGRA is surprisingly quiet. Astronomers call it a sleeping giant. It's not feeding on much right now, which is why the center of our galaxy isn't a blazing, violent quasar. But sleeping doesn't mean dead. CGRA definitely stirs for a midnight snack. When a gas cloud or an unlucky star wanders too close, the black hole's gravity shreds it, and as the material spirals in, it sends out bright flares of energy. We've seen these flares in X-rays and radio waves. In fact, evidence from NASA suggests CGR had a much bigger meal about 200 years ago, and we can still see the X-ray echo of that event lighting up nearby gas clouds. This tells us our black hole was a lot more active in the recent past, and could wake up again. More recent observations from 2024 have even spotted strong, organized magnetic fields spiraling around its edge, a feature that hints CGR might have a hidden, weak jet. The story doesn't stop with the black hole. The galactic center is a weird, chaotic place, and the more we look, the more questions we find. For instance, the region around CGRA is filled with huge clouds of ionized hydrogen gas. The puzzle is, what's sapping this gas with enough energy to keep it ionized? The known stars in the area just don't seem powerful enough to do it. And then there's the galactic center excess. It's a faint, mysterious glow of high-energy gamma rays spreading out 5,000 light-years from the galactic core. For years, scientists have argued about what causes it. Is it thousands of rapidly spinning pulsars all blurring together? Or is it something far stranger? Some physicists have a wild theory that could solve both mysteries at once. A new form of dark matter. Dark matter is the invisible stuff that makes up about 85% of the matter in the universe. We know it's there from its gravity, but we've never seen it. This new theory suggests that if dark matter particles are lighter than we thought, they could be smashing into each other and annihilating in the dense galactic core. These collisions would produce the exact particles needed to ionize all that hydrogen gas and create the extra gamma rays we see. If this is right, the heart of our galaxy isn't just a lab for studying gravity, it's where we might finally be witnessing dark matter in action, solving one of the biggest mysteries in physics. What a trip! We started by peering through a curtain of dust to find a faint radio signal. We followed the dance of stars to weigh an invisible giant, and then we linked telescopes across the globe to finally take its picture. We've met Sagittarius A, our galaxy's supermassive black hole, 4.3 million solar mass sleeping giant that quietly shapes its entire cosmic neighborhood. But finding this monster hasn't ended the story. It has opened the door to even deeper questions about mysterious energy and strange glows that could point us toward the true nature of dark matter. The quest to find what was hiding at the center of our galaxy has turned into a journey to understand the fundamental forces that built our entire universe. And it feels like the greatest discoveries are still waiting for us. If you're fascinated by the deep mysteries of our universe, consider subscribing and joining our journey through the cosmos. Let us know in the comments what cosmic question you want us to explore next.